Okay, so as I said, this is CS2300 Computational Linear Algebra. I'm going to start with a short announcement. I sent this out by email, but if you weren't registered, then you wouldn't have gotten it, so people might have added since then. There are a number of people that asked me, I guess in part because, one, I'm teaching this and you want to avoid me, and two, this is 8 a.m. on a Monday morning. They were asking if this class would be available in the spring. Until this year, the CS department has only offered it once time in the fall. Starting this year, they're going to start offering it in the spring. So if this is really impossible for you to make, you have an opportunity to take it in the spring. That doesn't mean you get to avoid me. So this course is going to provide a strong foundation in the practical aspects of linear algebra. I focus a lot on sort of practical and intuition and understanding, not as much on the rote implementation of stuff, but there'll still be a lot of stuff. We're going to cover linear algebra for vectors and matrices, which is actually some basic stuff you should learn from high school. So the first couple of weeks, it may seem like we are going very fast. By the Colorado math standards and the admission standards for here, you should have actually had vectors and matrices in high school, and I know many of you have not. So that's I'm covering it because it's really critical you know it. But for those of you who did not have it in high school, it may seem a little fast in the beginning. And we'll talk a little bit about how to make up some of that. And then we'll get into stuff like linear transforms, eigenvectors, linear spaces, computational issues like stability. This year I'm going to work in more computational aspects like machine learning and things because a lot of people are interested in that, and that's a place where linear algebra gets used a lot. Our textbook looks like this, Practical Linear Algebra Geometry Toolbox. You can get it in many forms. Hopefully by now you already have it. The bookstore should have some copies. You can also get it as an ebook. One comment, how many people bought it as an ebook? Okay, so just like in BLaw, for those of you who had me right, you're welcome to use an ebook, but in the exam when things are open notes, you won't be able to have your ebook. You can't use electronic notes. You can use electronic notes all you want in class. During our exams, they will be open notes, not open book, not open computer, just open notes. So if you're doing stuff, you can do that. If you're using the electronic version of the book and you decide you want to have your notes be basically files you printed out from the book, that is not going to be acceptable. Notes are things you wrote, not things that you copied and pasted in your notes. Some drawings from the book, I don't care, but if it looks like you've just basically downloaded, embedded the entire book and printed it out, which is actually make it hard to do anyhow, but if that's what you're going to do, then, and I see that during the exam, that will not be allowed. Don't get this older version, which is lighter yellow with 3 phoenixes on the cover. That's the second edition. If you actually got that already, you can make do, but you will get more confused because whenever I talk about chapters, I will be talking about chapters in the new book, so you have to do a little bit of mapping. Some of the exercises, which I probably won't give any exercises of it. So in that sense, you can make do with that, which is a little sometimes easier to find. Online, or if you rent it from Kindle or whatever, it's considerably cheaper. The used version will be cheaper as well. So this class uses what is called a flipped classroom model. I don't know if you noticed this yet, if you've looked at the syllabus. This class is, how many of you have had a flipped class before? Oh, good. So then this won't be such a surprise. Becoming more and more common. When I first started doing this here, people didn't really understand the process. So the goal of this class is you're going to, before class, watch videos. All of the lectures for all of the chapters are pre-recorded. They're already up on my YouTube channel. I'll show you the link in the syllabus in a little bit. You're supposed to watch those, and to help enforce that this year, I've added some online quizzes that are due on Saturday, so that by Saturday you're supposed to have finished your reading. I think they're doing Saturday, might be Sunday. Anyhow, so you're supposed to watch those videos, come to class watch the videos. You may not understand absolutely everything, especially how to solve problems and work things out. That's what we spend time in class doing. There are also videos from last year of some of that in-class stuff, which you can watch to get a feel for what's going on, although there won't be too many of those. And then afterwards, you'll have programming assignments and whatever, right? There aren't too many elements of this class in class that are absolutely critical. But when we talk about programming assignments, that for many students turns out to be critical. So I know it's 8 o'clock in the morning. If you feel you're going to skip this class, make sure you at least get with a friend when it comes to understanding what the programming assignments are. If you've not had me before, right, some of you have, right, my assignments are intentionally sometimes vague, right, because that's the way the real world works. Your boss does not say, here are the 500 steps it takes to solve your problem. They're like, here's a 30-word description of the problem, go solve it. and it's up to you to work through some of that. So if there are things that are vague, it's up to you to figure them out, ask questions, or do whatever. I will answer some of those questions in class when we start describing them, so it's to your advantage to be there. So I do this flipped classroom. Some of you will, how many of you hated flipped classrooms when you had it before? Let's see where I'm getting it, okay? So those of you, well, you're gonna hate me again. But I do this because studies have shown this actually helps the long-term learning, and especially in classes where some students struggle and some find it easy. This class, because of the way it was designed, we have a bunch of seniors, in fact, a couple of fifth-year seniors, and we have a couple of freshmen, right? And so the spread in this class is very large, making it very hard to say everyone is at the same exact point in time in terms of their learning. And in addition, those of you who struggle can now watch these videos as many times as you want, stop them, pause, rewind, go through them. So in the long run, this should help your learning, even if it's not how you like things. We're going to do lots of things in class where you're going to work together with someone in the classroom. That's also why I wanted Engineering 103, because of their longer tables, a little easier to work together. In this classroom, it's going to be a little tricky. You and a partner will be able to solve problems together. So it's, for exams, it's going to be spaced out. For the rest of the semester, I recommend when you come in, if I don't have a seating chart, which I'll get back to, then you partner up with somebody and sit next to them so that the two of you can discuss the math problems as we try and solve them in class. So talking with your neighbor when I tell you is fine, and there'll be other times when I say not. Okay, so we're going to try and spend lots of our time down here in the group discussion and practice session of participatory learning methods, which increase your retention rate of material. Okay, and so I want you to do stuff and remember. In various studies, so, and I'm not going to spend this because a lot of time on this, but in people who actually go through this flipped classroom with active learning, the number of students who fail the class goes down. That is true in this class. If you actually watch the videos, come to class, go through this, it's hard to fail. The only way to fail is to simply not do the work. Well, and you have to do the programs. Right? But very few students fail this class who actually were in class doing the clickers and watching the video. It might be painful, but you will make it through and learn some of this stuff. And if you start blowing it off, you will find this class grade age. Okay. So the science of how we learn has really changed over the years, and so now we know that when you're trying to do a lot of these things, we go through what's called an desirable difficulties and effortful learning. So when you try and learn something, if you feel that you're getting it wrong, that's actually probably good for your learning, right? As you overcome that, you get it wrong, you work through it, with practice you get better and better, okay? You're actually used to this. If it's too simple, you actually don't learn very well. So the worst thing that happens is when you think you know it and you don't. We'll go back to that. So the more complicated the task, the longer it takes for you to learn this, which is why in this math class, we're gonna have a bit of repetition in some of this. So when you work through it, and the studies have actually shown that what's called the desirable difficulties, and this is a balance between just hard enough that it really forces you to keep learning and too hard and you get too discouraged. Some of you have a higher level of resilience, and I could be running this class at 30% success rate and you'd keep going. Some of you are going to struggle at 50 to keep going. I will tell you, I aim in this class for 50% on just about everything. The average on an exam is around 50%, and that's a B, right? So you can't just use raw scores, which some of you are used to get a feel for what's going on. And many of the assignments, you will feel you're going to struggle with them. But I'm also trying to push the best students in this class for whom the exams are easy. While the average might be 50, the best students will get 90, right? And so I got a wide range of stuff going on. So don't worry about the fact that you're making errors. If you keep improving, you'll get better, right? And you'll be getting enough feedback from me in terms of your grade. On every assignment, I grade things curved separately. So you'll know if you get an A, B, C, D, or F on that exam or on that programming assignment or whatever. I'm going to sort of skip over that. So the illusion of knowing. This is a serious problem for people in math. It's especially a problem for a class like this where some of it was, for many of you, was covered in high school. And in the beginning, it's like, oh, I know that. And then all of a sudden, something deep happens and you don't know it. But you think you do because you've got this, what's called the illusion of knowing. It's especially true in math classes where you can regurgitate the exact phrase used in the book, but you can't actually apply it to anything, right? That's a different part of the illusion of knowing. You know the words, not how to apply them. And I'm going to try and make you apply them a lot in this class, which is part of what's going on. If you have problems in your learning, some things to do to help you combat that. If in class we're doing things that you think is well known and obvious to you, figure out how to draw it instead of use formulas. Or if you're used to drawings, figure out how to do it in formulas. There's two different ways of looking at almost everything in this class, algebraically and geometrically. Swap so that you're forced to drive the learning on both sides. Before you go to do some stuff, try and formulate your own question. I'm going to drive that a little bit this year because in your journals, which I'll talk about in just a little bit, you're going to be making up questions, clicker-like questions, so you get used to them and so that you're thinking about the kinds of questions one should be asking from the book. And one of the nice things about learning math, and for our textbook as well as most of the others, you can actually do a lot of self-quizzing and testing yourself. The back of the book has answers to about half the questions in the chapter. So if you've not noticed that, that's true for most math books. You can go through them and say, I'm going to try and answer this question, and then see if you can get the answer in the back. Okay? And if you go through that and you're getting them, fine. If not, work through it and see how to get the answers, and you'll get better at that. Okay, so for people that struggle in math, how many of you struggle with math? Okay, well, hopefully this class will get you through some of that. A couple of things about this. Many people who have problems with math have a learned helplessness. You've decided you're bad at math. I can tell you that this is a problem for many students, and you can probably learn to overcome it. Some of you have had me before and you know this, but I'm dyslexic. I had an extremely hard time learning to read, and I still never really learned to spell. And grammar for me is, you know, I get some of it, but when I write, especially when I write, without having a proofreading or anything, it's horrendous, right? So I still struggle with it, but I work at it all the time to get better. I struggled with math in the traditional sense because of dyslexia. I will reverse numbers and whatever. In classes that make you add numbers, I will always fail. But if you ask me to draw, four-dimensional cube and transform it to another one, I can do that in my head, right? So very weird. But learned helplessness is a problem. If you feel you're struggling with math, start in this class very aggressively. Watch the videos, work through it, and you can get through a lot of this stuff. The other problem that I see a lot are attention problems. This class is boring to many of you. You are here because you have to be, I understand that, and that's going to make it hard for you to study. Well, there's not much I can do about that, but once you recognize it's an attention problem, maybe you can do this by breaking it up to watch the video for 15 minutes, take a short walk. Watch the video for 15 minutes. It'll lengthen the total time, but you can get through it that way. Be a little careful about, I'm going to watch the video while I'm also playing a game. That generally doesn't work very well. Or I'm going to watch the video while the football game is on TV and whatever. Right? That's not probably going to work as well for you as well. So if you have gaps, if you really struggle with this first programming assignment that I'm going to give out today, and it is nearly impossible for you to do this, then your programming skills may be a problem for you in this class. Right? We move this class to have a prerequisite of programming, but some students come in and they still are not very good at programming. This class is not about programming as the only thing, but you cannot really do well in this class if you cannot program. And if you really have problems with algebra, the biggest thing I see with students struggling in linear algebra is they can't do regular algebra. And they struggle with, if I gave you an equation with x on one side, y on the other, try to solve it so that y is on one side and x is on the other. If you struggle with that, you're going to struggle a little bit in this class. That doesn't mean you can't do it. You're just going to have to work through that and get through all of the processing. As I said, math books come with answers. So you can always work through that. There are videos for this class, and most of them are going to be called various things like chapter or whatever. Some are not in the book. If there's a video called lecture or whatever, that's something that is not in the book. And we'll have a number of those later in the semester. And then if I put some videos up from class, they'll be called class. So I have a naming convention so you can just look at the name and have a feel what's going on. If you find my videos are not understandable, which some students do, because they go pretty fast, stop and rewind, but especially in the beginning, if you're reviewing basic matrix stuff, I don't spend a huge amount of time going through all of that as you might want. There are plenty of other videos on linear algebra like Khan Academy or some other place where you can go through that. If you're struggling, you can't find a video on a topic in YouTube, let me know, I'll find you one. This was also part of how I made it through all of my math classes and lots of other classes. I generally had 3 textbooks for every class because I would read them incorrectly with my reading problems, and if I read a different version, I would read it differently and therefore find some middle ground. So, So despite the fact that in class we're going to be doing mostly problem solving, I still recommend you actually take notes in class, but I especially recommend that you take notes while you're watching the videos, right? Because when it comes to learning, taking what you've seen and writing it down actually helps people remember, which is why we do notes in B-Law as well, right? So if I call on you in this class, and because the class has gotten so large, I'm no longer doing much of this, and it's in your notes like in B-Law, right, you'll get points. But I probably won't be doing too much of this because I can't see the notes in the back of the room, and I'm not going to easily walk around and whatever. But I still recommend you do that. So we're going to do clickers. I'm not going to spend as much time on clickers. But some students, well, so in terms of the learning studies have shown it helps the average student learn. That doesn't mean there's some students down here that hate clickers, right? With 75 students in the class, 5 of you will hate this class and hate the use of clickers. I'm sorry, but I'm trying to get everyone to learn better. So for those of you who hate them, you can complain. It's not going to change the fact we're going to use clickers. If you really struggle with how to use them, we can come to my office hours, we can go through them, but they're really pretty simple. So in class, we're going to be doing things, right? I will post some questions on the screen, and some of them will be based on the pre-assigned reading and homeworks. Most of them will come out of the book, but with different numbers and different applications. Some of them will be literally out of the book, others will be a further application. There'll be a range of difficulties. So when I go through the clicker questions, some will be really easy and some will be much harder. That's a range of difficulties that I expect to see. You're going to use your clicker, and I'll go through that, right? The results are tallied, and often I will display a graph, but not all the time, because we'll see when we go through these, we'll start seeing. Sometimes the graph gives away information I don't want to share yet. Sometimes you get to have a group discussion and revote. When I do that, if I have a first one, I generally do lots of these where you work on it yourself and then you work with a partner. So remember that. Don't start instantly working with a partner when I go through that. If I do it twice, you get credit for it twice when we start talking about how they're going to use for credits. We'll generally discuss the questions and the answers. Sometimes we'll only discuss the right answer. If there was enough people that got things wrong, we'll talk about how you might have gotten that wrong answer and what leads to that thought process. And you're going to get points for some things. If you answer 75% of the questions of the day, you get a point. You get a point for every question you get right, so you're going to need to get lots of them right, or around 80% of them right to get an A out of them, and 70 to get a B and whatever. So the way I've structured this, some people really freak out, oh, what happens if I have to miss class because we're using these clickers and they're counting towards my grade? The way clickers will work, I will have about 130 clicker points before the midterm, and that you get 2 clicker grades, one before the midterm and one after. You're going to be scored out of 100, right? So if I have around 15 to 20 a day or 30 a day, then you can miss 2 days over the entire semester and still get an A on clickers. You can miss one in the first half of the semester, one in the second half of the semester, and you can still get an A, right? So you don't have to freak out completely in terms of what's going wrong with them. So a clicker is required. You can purchase it through the bookstore. Physical clickers like this, I don't care if it's a clicker 1, 2, or if you're using your phone and using that. Reef polling on your phone or laptop, either of those is okay. Just to make sure people understand how to use your clicker, if it's your first semester, you hold the button down on the bottom, and a blue light shows up on top, then you know it's working. We're going to be using, when you get asked a question, you enter one of A, B, C, D, or E, depending on how you want to vote. For some questions, you'll be able to talk within your group. So when I go to vote, in fact, the poll is running down, right? So this actually tells you the poll is running. So the poll is running, so if I click an A, it tells, so you saw the number go up, and a little green light flashes telling me it's voted. If it flashes red, you need to vote again, and it might mean you're on the wrong channel. If you're not sure, you can keep voting as many times as you want. I can change my answer. The final answer is the one that will be recorded, so if I change to A, B, and at the end it'll be B. Okay. So the one thing about that is you want to be careful about accidentally hitting it. So like if I go to accidentally click it and I click it accidentally, I've just changed my answer, which will matter. When you go to register it, so I'll show you the registration side in a second, but there's a number on the back of your clicker which you can type in inside of Canvas. Well, actually, Canvas sends you to a website where you then type in the number and whatever, and that'll get you through it. This number is actually really important, so if you just bought your clicker and you're going to use it for the next couple of years, my recommendation, put a piece of tape over it, because once that number gets erased, it's really hard to find out. For many of the clickers, but not all models, inside the battery compartment is another sticker within the same number in case you bought a used one and the number's gone. And if you bought a used one and the number's gone, you can't find it, come to my office hours. I can set up my base station and you'll be the only one in the poll, and then I can figure out what your number is. Oops, so this is last year's notes. So, and the other choice you have is using the iClicker Reef app, which comes as phone apps and PC, and apparently it doesn't work with old versions of the phone, right? So, what was your OS? S4. So yeah, so you're like pretty old. So okay. So it may not work with really. So now you might actually try using the web app on your phone, because that's the other way you can do it, is through the web on your phone. Okay. And so you can use your laptop in this class. And I see some various people plugged in with laptops, whatever. You should just get extension cords so you can use them. But I have no problem using your laptop in this class, and I'll come back to that in just a little bit. If you're using it for Reef polling, I want you to be able to use it, but if you lose your privileges, that'll come back up. So anyhow, to register it, inside of Canvas, there's this little button that says iClicker Sync. And if you didn't see that before when you're on Canvas, that's because they didn't enable it until like 6:30 this morning. So now it's enabled. And so you click on that, it'll actually take you to the Reef polling. The class should be there. You can go ahead and register your iClicker. You don't actually have to do it, even if you have a physical iClicker and you don't want to do this today because you don't have your laptop, don't freak out. The system will record all of the polls we get. So if you click on this today, you will get an answer that will show up in my log. And then later, I can associate that number with your name. Okay. If you're using the phone app or the web app, you'll generally see a question on the screen. It's set up so it's take a picture of this screen with the question, save it for you to be able to review later, and then you'll be able to answer on the bottom, and it'll tell you when the answer is received, so there's some balance. The one good thing about this, the one reason I actually recommend the iPhone app or the phone app or the web app is because later on when you can review and go back over, here's what I answered, right, and see your answers. If you use these guys, you can't review your answers, but your app will keep track of it. So if you're struggling, machine, should I buy the physical one or the phone one? You haven't decided. I would go for the phone or the web app, and I think if you pay the fee, you can use either laptop or phone to go back and forth. But then you can review your answers. If you're using these the physical clickers, the default frequency we're going to use in this class is AA. Given where we are physically located, I don't expect there to be much of a problem with this because I don't think anyone else is using clickers at this time in this area of the building. If it changes, I will let you know. And if it changes, at that point in time, I will tell you how to change it, but you basically hold the button for a couple seconds and then you type in a new frequency. So don't forget it. I keep a bag of extra ones. So I have, I don't know, 8 extra ones. If you forget your clicker for a day, you can borrow one. If the first time there's no penalty. The second time you only get it if somebody else doesn't need it, which generally turns out to be the case. And after that, even if no one else needs it, you can start losing points for forgetting your clicker all the time. You can also use as a 14-day free trial for the phone app or web app, so you can always do that if you forget a physical clicker one day. But I don't want you to lose points just because you can't get a clicker. Okay, if you bought a used clicker, the batteries may or may not be in good shape. I definitely recommend you try replacing them. You're never going to work. And for some of the older clickers, the ones I have, and I normally carry extra batteries just in case. If you buy them or you find them and they have these Duracell batteries, which are a very common battery, for reasons I do not understand, they're about 1/10 of a millimeter short. But these have horrible springs. Normally batteries have like a spring on one end to make everything fit. These have really horrible springs, and so some of the Duracell batteries will simply make them not work. That does not mean you bought a defective iClicker, that your iClicker is somehow died when you put new batteries in, it doesn't work. It just means they're a little bit short. You can actually fold up some aluminum foil to make a nice thick wad and stick it between them. It'll probably make them work, or you can just get other batteries. Don't use rechargeable batteries. The voltage is lower and they may work for about 5 or 10 minutes and then stop working. So bring your clicker to class. If you have problems with it, come visit me during office hours. We can work through that. Some grading options in this class. So this class has 2 grading options. One of them designed for people who already understand the material. I'll come back to that one. The basic grading option, which almost everybody will get a higher grade in, the first part is your learning participation. Discussions in class, if I call on you and you get points. Office hours, clickers, and journals. And they're broken down. There'll be 2 clickers of 6% grade each. Class office participation. Some of you are a little bit introverted and you don't want to speak up in a class of 70. That's okay. If you visit my office hours, I count that as class participation. If you visit my office hours and you've shown you've done the work. If you visit my office hours and you show, I haven't even read the chapter, but I have some questions on it yet, you won't get as many points out of that. So, the journals, you will have weekly journals. They count for 6% of your grade, and quizzes, 8% of the grade. So the quizzes, I shifted compared to last year. The quizzes are, how many people have already done the quiz? Anyone? No. So quizzes are basically 3 questions from the chapter, and if you've read the chapter, so watching the videos is not sufficient, and I will probably, and Chris, you have to remember this, right? We're making questions. At least one of the questions will not be answerable completely from the videos, but will be answerable completely from the book. So the videos are not a replacement for the book. They're in addition to the book like it would be in a regular class. The quizzes are open notes, open book. You can go through them because it's there. Control F or find won't help you much even if you have the online version book. So the quizzes are pretty straightforward. And they're really just a forcing function. If you've done the reading and you've got through the book, then you'll be able to answer those questions. They're not really hard. The harder questions will be in class. Very few of the quiz questions will be calculation-based. They will generally be terminology-based. Because if you don't understand the terminology when we start talking about problems, you really will have a hard time understanding what's going on. Okay. There will be 5 programming assignments, 4% each. The first one is pretty easy, and then they get medium hard, and then the last one's generally pretty hard. There's a midterm and a final, and the final may be optional. Okay, and that's something that if you have a grade of B or better, by the time we reach the final, then your grade on the final cannot hurt you. It can help you. So if you have a B and you take the final, you can get a B plus or an A minus or an A. Right? It's 25%, so probably only from a B you get to a B plus or an A minus depending on where you are. But you can never go down, which means if you don't show up for the final, you can't go down, so it's optional. Officially, I can't let you out of the final. I have to treat everyone the same. So this grading option lets me treat everyone the same. Anyone who's got a B, the final can't hurt them, can only help them. Everyone else, the final will count. Any questions on that? Because this is something, so. I will let you know about 5 days before the final what your final grade for the final is, and you'll get a very explicit email. The final cannot hurt you, or you must take the final, just in case there's any questions. No, so every assignment is graded on a curve. So, and I'll talk about that in just a little bit. So after I curve an assignment, you'll get a grade for that assignment on the A to F scale, 0 to 4.33, 0 to 4. Okay. So things like clickers are graded completely different. So everything's curved in a different way depending on how they come out. So it's not like there's a 50% as a B. I aim for 50% to be a B. That doesn't mean I'll hit it. Sometimes I will make up much easier questions, and the average on the exam will be 70. Right? So we'll see. Okay, so the second grading option, which I want to discourage you from, but every year some people do it, and that's your choice. The online quizzes will be 10%. So you have to keep up with the class. 5 programming assignments, 5% each, so they're worth a little bit more. 30% for the midterm and 30% or 35% for the final. Okay, notice there's no clickers, there's no journals, there's no class participation. This is the option for those of you who simply can never make it to class or feel you already know this material, so like, why should I bother? I'll just whiz through this class and do it. That's fine. Every semester, out of like 70-some students in this class, 2 people will probably use this grade option and get better grades with this than they would under the first grade option. And you almost always get better grades under this if you never attend class. But if you attend class, the other one will be better. So I'm not going to be making things easy, and I have more to cover today, so I'm going to go through this. This comes back to how material will show up. Material that is difficult and more difficult and more difficult, which is what we're working in this class, you tend to learn stuff. You'll also find that I do a little bit of spaced practice. We'll do chapter 1, 2, 3, 4, and then I'll hit some 2s again, right? So when I do clicker questions in class, they won't all be from this week's chapter. One that leads you into anticipatory illusions of knowing. You think, oh, this question must be from chapter 4, therefore I'm going to apply chapter 4 to it. The world doesn't come sequenced like that, so I will toss in questions that aren't from this chapter. Don't always presume things will be put together. And I already covered all that. So hopefully, in addition to helping you learn math and the linear algebra in this class better, I also want you to develop a growth mindset. I want you to understand that you can make it through difficult things. And if you come to my office hours and work through problems, right, you'll get better and better at this. And you can. It's not impossible. I know I'm somewhat scary. I'm not quite sure why. I try not to be scary, but I am. Come to my office hours. I always have a bowl of candy in my office, right? There's chocolate, things to help you calm down. And hopefully we'll get through getting through this learning. Okay, so why are grades curved? And actually, in my view, why are all grades always curved? So, this just some comments to go along with the story here. But grades in this class are me reflecting what you've demonstrated you've learned. And effectively, attendance counts in class participation. Just being in class is counting somewhat, but it's not going to get you very far to just learn. Okay, in terms to just show up. You actually have to demonstrate to me that you're doing learning in terms of the clicker questions, in terms of the journals, in terms of the other assignments. Okay, so you shouldn't just expect high grades, but it's not that hard in this class. So grades are, why is everything you've ever taken graded on a curve? In my view, there are two approaches to giving grades for a class. I can make up questions, and if I'm really, really good, I can make up enough hard, medium, and easy questions so that the grade distribution is such that the expected number of students get an A, B, and C. Okay? But that means if I make a mistake, it's really hard to recover. Second, it means I don't push people as hard. So I grade everything on a after-the-fact curve or post-hoc curve. So if I actually look at, this is from the fall 13 midterm grades, here's the actual number of students who got below a particular score. And you'll notice this is not a nice linear curve. There's a couple of dips and bumps in it. And the frequency of scores, the exam was out of 200 and something, 220. Right? There's a number of students who got 170 or higher, a lot more on the 150, 130, 100, or whatever. I grade out of these larger number of points because it makes it easier for me to give partial credit when I'm doing stuff, and also because then if you get a 90, right, you don't freak out. For some people, they just can't handle curving grades. In my class, when I curve, the curving almost always improves grades. Right? So if I use the raw percentages versus the curve, because I aim for such a low percentage, it's going to hurt you. So don't freak out if you get a lower number. But if you don't have to worry about the curve, if you don't worry about the curve, do the best you can, and that's what's going to be reflected in your grade. I would not give, despite the fact that I curve, if everyone actually got 100 on an exam, I would assume somehow they cheated, but after that I'd figure out, okay, well, that's okay. If they really did get 100, I can give out all A's. I do have a desired grade distribution, okay? And you'll see from the fall 13, right? There were a few people down here. Most of the F's simply never showed up in class, didn't show up for the final. Right? There's always a couple of students that aren't paying attention, doing anything. The D, well, D's will happen, but you really don't want to get that. But if I didn't curve with the way the math stuff goes, more people would be at the lower end of the curve, so don't let that worry. The last thing comment about in terms of the grading is how much time you spend. So this class, like most of my classes, I expect you to spend outside of class 6 to 8 hours in addition to class time per week. Some of you will be able to get by with 4. Okay, if you're really good at math, this is easy. You'll get by with 4. Some of you will really struggle, and it'll be 10. Okay, and because we have programming assignments, the upper bound is 168 hours in a week, because that's how many hours in a week. Some of you will never figure out how to debug your programs. If you're struggling with programming, don't view it as you can't come to me. Right? You can come to me. You can also go to the Math Tutoring Center, Math Learning Center, where there is a there's a tutor who can help you with basic programming things. I will give you a caveat. If you go there and you ask them some linear algebra questions, they may not understand how this class is working, and they may give you slightly different answers. Right? The math will be the same, but if they tell you to do it a way differently than I do it, than we're doing in class, it may help you learn. It may hinder your learning. That depends on how you look at it. There's many ways of solving our problems. If you get the right answer in a different approach, I won't take points off for that. But if they're telling you stuff about the programming assignments like, no, here's what he means when he asks that, that's not something you should trust a math tutor for. If you're not sure what the problem is asking, ask me, not them. So, and then Chris, please stand up. So this is Chris Breeze. He is our TA for the class. He will also be having office hours. They will be posted. I think they already are posted in the syllabus. And you can go to him with questions as well. So he's survived this class. Actually did okay. And so, he has experience in terms of what's going on. If he tells you, here's what he means by this, I will trust his interpretation. And if he and I disagree, we'll work that out between us. And I will not take points off because you listen to him. If you listen to math tutors, I have no way of verifying anything, so I won't really go with that. So, for those of you who have your clicker, actually, I'm going to take a quick mistake. I'll come back to that. If you have your clicker or Reef polling and you haven't registered yet, I have to go here, and now I have to go here. Okay, so as I said, you go down here, come on mouse, and you click on iClicker Sync. Follow that, that'll open up a web browser. If you have an account, fine, log in. Oh, I'm already logged in, and I'm an instructor, so it always looks different for me. I keep forgetting that. But that will let you go ahead and register it. So now I want to go over some of the syllabus stuff. I already hit some of the highlights, but a couple of things about our timeline. So here's our approximate timeline. I will generally try and stick to this, but as the semester sometimes goes easier or slower, I'm going a little bit different than I did last year, so we'll see how that goes. So this will tell you in general when a program is out, when a program is due, right? And we'll show you that in this Canvas stuff as well. And these are the readings and the associated videos that go with it. When we get down here, you'll see there's less and less reading because when it gets to applications, there's a little bit of applications in the book, but not very much. I will be adding a lot more when we get to that part of it. Grading options I just talked about. Programming assignments. So this semester, we'll have 5 programming assignments. Your first programming assignment is solo. You will do that one entirely on your own. After that, assignments will be optionally in pairs. Not groups of 3 or 4, pairs. Okay? The programming assignments can be done in whatever reasonable language you want. Java, C++, C#, Fortran. If you have a language other than Java, C++, C#, I have to check with Chris because he has to grade them. Python. Python's okay. Anything else more esoteric, come talk to us, we'll see. Like last year we had somebody want to do it in Go. It's like, no Go. But you will be able to work in pairs. I will actually do something a little bit different this semester because I found that last semester I had a couple of people that were in a permanent pair, one of whom did really well and one of whom did poorly. So I will actually be limiting the number of times you can be paired with the same person to twice. So there are 4 programming assignments to do as pairs, so you'll have to pair with at least 2 different people as you go through that, which will help you with some of your teaming skills. You can also choose to do those programming assignments entirely on your own. Right? There's not a big difference in them. It turns out that having 2 people allows you to have discussions and whatever, but the amount of coding, the longest program, if coded efficiently, will probably be on the order of 120 lines. Right? If coded very inefficiently, it could be 1,000, but inefficiently, you can do whatever you want. You could write a novel in the middle. And it'll depend a little bit on your programming language and how much you reuse stuff. So one of the things I will say, in your programming assignment, you are allowed to use libraries and resources from your language. In fact, you're encouraged to use libraries and stuff from your language. So if your language has a library for doing I/O or a library for multiplying matrices, you're allowed to use that unless I explicitly say you have to code your own subroutine or subprogram. So in general, don't reinvent the wheel. It's not good computer science for you to say, look, I'm going to write my own matrix multiplier even though my language has one built in. Right? So I will tell you if you need to implement stuff yourself. In general, I try and make my assignments so that there's no way for you to find their answers directly on the internet, and they're not directly solvable in the language of your choice. So you have to actually think about how to apply stuff. So in your team programming, each of you will be responsible for having your own Git repo. I will talk a little bit about Git in a bit. And each of you have to turn in your own answers. Okay? And in Canvas, you will be also turning in a personal statement of who did what and how you think the grade should be split. Teams do not necessarily get the same grade. You can get an A and your partner can get a B, or an A and a C, or an A and a D, depending on who justifies what they did. I don't have as much interaction as I do in this class with the teams in the Innovation Core, but if I feel there's a discrepancy among the two views of who should get what grade, I will have a conversation with the 2 of you and I will resolve how to assign the grades. Your recommendation is not the grade. My determination is the grade and how things get split up. Any questions on that? Okay. Journals. So the journals are already posted for the entire semester. I actually don't want you to turn in the journals early, so I may actually go turn some of them off, because last semester I found somebody did like 3 journals like for the next 3 weeks. It's like, no, you're supposed to do them 1 a week. So journals, there will be 12 journals, 10 points each, and they're graded on an absolute scale. So if you get 100 journal points, you get an A+, and you work your way out of that. So there's no other curving. Journals are relatively simple. In general, they will have 3 things you have to do, and they are, I'll come back. So when you click on the journal, but basically it's what you learned over this week, what you struggle with, and then make up a clicker question and its answer. So you sort of think about what some questions would be good for this. And yes, in case you're trying to figure that out, I hope to be able to reuse some of these clicker questions in the future years so that I have a broader range of what students think are good questions for this chapter instead of what I think are good questions, because maybe my clicker questions are off. I already mentioned cell phones, right? Computers. You are welcome to use them. If I feel you're sitting in the back row and you're playing games, or if you are clearly not really paying attention, I may reassign your seat, generally down here, so that I can keep a better eye on you, although that's not a good seat. I can't see Chris, but I can rearrange your seat. If you abuse your computer privileges or your phone privileges, you may lose them for the semester. And if you do that, it doesn't matter if you're using an ebook or whatever, or using Reef, whatever, that's your problem, right? I have not in the last 2 years taken away any privileges, so it's not very common. You have to annoy me enough with what you're doing. But if you have 2 or 3 people crowded around your screen because you're like, really kicking it in some game, I'll probably have a problem with that. If your cell phone rings more often than mine, and it doesn't disturb us too much, it's not a big deal. But put your phone on vibrate, and hopefully we'll be fine. Cheating. This is something I don't take lightly. If I've decided there's cheating, I will take it to the Dean of Students. Even if it's your first offense in this class, it doesn't matter, because the Dean of Students might see a pattern across classes. In general, if you cheat, I give you a 0 for that assignment, and individual work means it's yours. So if you're working in a program as a team, and then there's some individual assignment, there's only a few that I'll give out, then that's a problem. If you partner with your partner on that. If 2 teams get together and work on the same problem, that's also cheating. It's a little harder for us to detect, but we have detected it multiple times in the last couple of years, and you all get 0s for that. And you forever lose your ability to work on a team, because we can't trust you anymore, right? You will be doing individual assignments, and we'll be following you a little bit more closely. That doesn't mean I want to discourage you from ever talking to anyone else in this class. You can talk to people. If you're talking with words and hands, that's probably okay. If you're talking with typing or paper, you're probably crossing over the line. In fact, by the time you're typing, you've crossed over the line. Writing, you might be drawing these equations to help understand it. That's okay. If you're helping somebody understand what is the assignment about, or understand some basic math questions, that's fine. Don't say, here's how you solve it. Okay? If you come to my office and ask me questions, I will never tell you, here's how you solve it. I will keep asking you questions and driving you down a path. That's not cheating, right? So anything I tell you is not going to be considered cheating. So if you find material on the internet, you are free to use it if you cite it. Okay? You don't have to cite anything that is built into your language. We understand the language and the standard libraries that come with it. If you find some weird package that you can pip install that somehow magically solves some of our problems, you need to cite it and explain how you are using it. If we decide you use those things without citation, then you have crossed the line into cheating, and we may or may not give you any credit for it. We may take off more. Emergencies in class attendance. This class is early. If your car breaks down and doesn't start or whatever, shoot me an email is the preferred way for me to get it. I'm probably not going to respond in real time and say, that's okay. I record each of the classes. I will be uploading them afterwards, so if you miss it, you can always find out what was happening in class, but you don't get to make up your clicker points, so you don't want to have that happen too often. If there is a real medical emergency or something else, I may actually give you some way of making up some clicker points. That's an uncommon thing. It happens once or twice a semester, and I normally make up a special extra credit assignment for that person to let that happen. So don't feel, oh, I just screwed up. It's like I was in a car accident. Car accidents are well beyond your control. Sleeping through the alarm because you beat it up when it buzzed at you and you killed it, right? That's not a problem that I'm going to say, yeah, I'll give you an exception for that. Seating. So in general, it's going to be first come, first serve. Students who sit in the very back row, right, generally don't do very well in this class. I'm not sure why. Maybe it's the distance, you can't hear as well. There's lots of room in this class to sit much farther forward. They were going to originally move this class up, so we needed all the room. We don't. You can probably all just sit in the front. If I decide for some reason you are not working out well where you're sitting, I may move you down to the front. 2 or 3 times throughout the semester, I will actually post a seating chart. My seating chart will only use the first 3 sections given the size of this class. And when you come in, if there's a seating chart on the front with your name on it, that tells you where to sit. There'll be some extra experiments going on in this class that I will talk about later. I'm not going to go through them today, but I will also be regularly filming this class because I'm studying student engagement and facial expressions and how to measure if students are engaged or not. And so that research work depends on actually having a class where I will measure engagement. And so I will have some of those, and so there'll be a camera posted in 1 or 2 places. This room's big and wide, so I might need 2 cameras to make it work. Learning objectives. So I've already mentioned the book. The course videos are here. There's the flipped ones, and then the videos from the classroom exercises. As we go through those, that playlist will keep being updated over time. And then here are some other sources for learning. If you are struggling with the sort of algebra level, there's a good reference here for pre-calculus students. For linear algebra, goes through a lot. It goes through a little bit stuff a little bit more slowly. And if you are more visual, this one's fun. Vector math for 3D computer graphics, an interactive tutorial. It's actually interactive graphs. You can move things around and help build up your intuition. So if you're struggling with that side of it, it's a good extra resource to look at. The course summary, right, the sort of syllabus by week. One thing to note is that when they say, like, here's program 1, I'm giving this program out today. It's already posted. Most of the assignments have like a 2-week notice. It is not good to wait until 3 days before the assignment and start it. That's Friday, right? You may or may not get me to answer email and stuff on the weekend, but you don't want to be struggling with what is this assignment doing. My recommendation is make sure you understand exactly what the program is going to do and start, like, here's my design of how I'm going to solve it. And once you're sure about that, then you can, put it off for a couple days if that's what you need to do to fit things in your schedule. But some of the assignments will be intentionally vague that you have to work through. And if you get them, fine. If not, you're going to want to be able to ask questions. So don't wait until they're just before their due date to look at that. So that's one disadvantage of it. It's not showing you when it's assigned, it's showing you when it's due. So you can sort of see here the videos and whatever. So for each week, I will be posting the videos, so you don't even have to go to the channel. Like, they'll be posted a week or so in advance. This will take you to a page that has the videos embedded, right, for each of them, and then you can watch them. So you don't have to watch them in one setting. I just trying to make that easy for you to get to. Any questions about the course structure, syllabus? Oh, 2 other things. Disability forms, if you have any of those, you can bring them to my office hours, which I forgot to mention, but it was there. My office hours are, very beginning of this, Monday, there we go, Monday 11 to 1 or by appointment. I'm generally around Monday and Tuesday mornings, but we have lots of meetings to get scheduled on Tuesday, so by appointment I can generally schedule something on that. Email, preferred way to contact me is email. I read my email, 20 times a day. Like, it sits open on my desk. Text messages, I sometimes go 2 or 3 days before I notice I have one. I'm not just a texter, so if I don't pull up my phone, right? So whenever I'm in meetings, and I spend the majority of my day in meetings, my phone doesn't ring or buzz. And then when the meeting's over, it turns back on the alarm, but it doesn't notify me that I had messages. That's why I can go 3 days and not notice them, because my phone doesn't buzz and I don't notice it's there. So definitely better way to contact me is by email. If, however, you send me email and you don't get an answer in 2 days, assume you will never get an answer and try again. Because if an email gets marked as read, I don't go back generally and remember, oh, yeah, Leonardo sent me an email, I should answer that. No, if I accidentally look at it on my phone, it gets marked as read, it's gone. And then if you send email from really random places like Yahoo, Gmail, Hotmail, or whatever, I have an extremely aggressive spam filter. I filter out between 500 and 700 messages a day. So I don't look through them. If it's in my spam bucket, it's as good as gone. And if you're sending from a place that's not authorized, your chance of getting in the spam bucket is very high. If you need to send it from some weird account, if you put the word innovation in the subject, my spam filter looks for the word innovation in the subject and says, oh, I will let that through, because I get parents who want to ask me questions. Okay, we will generally be taking a break. This class goes until 10:40, so we'll take the break at around 9:30. Okay, so hopefully by now you have, if you have your clicker, so today's clicker points are freebies. If you don't have your clicker, don't worry about it. I'm actually not going to be grading these in any way. If you answer clicker questions today, you get participation points. If you don't, you don't. So it's not going to be a big thing. But this will help me understand where some people are. So let me kill this one off. Okay, so I'm going to start this up. So, skills assessment. What is your feeling of your understanding of basic math, algebra, vectors, and whatever? So, tell me with respect to those. Actually, we're going to do this. How did I make this one? Try to reduce the number of slides. So the first question is understanding basic math rules on the A through E, where A is anything but graphic visual, B is better with words. So this is answering just for A. We're not yet to matrices. We're going to do 4 of these. This was a bad idea. I did this last year and I forgot to change it back. So we're just dealing with basic math. We got 27. I have no idea how many total people there are going to be today. Everyone voted? Anyone still? And these are set up as what are called anonymous polling. All I know is that you answered. I never get to see your answers. I just look at the distribution for me to get a better understanding of how I have to cover things. Okay, so that was A. Now let's do B, understanding of basic algebra. More than last time. Okay, so now we'll do C, understanding of vectors. Okay. Next one. Are you a graphically or visually oriented learner with now a new scale for those? So balancing between visual or algebra and graphics. Did I skip the matrices one? Okay. Well, let's do the graphical one and I'll go back and... questions. Okay, so now we'll do understanding of matrices. Okay, slowly increasing the size of the class. We're up to 50 now. Okay. Next one, preferred programming language. I will use this mostly. I will give some coding examples in class and maybe on some of the other videos. We'll see how it goes. I didn't do this much last year, and then students in their feedback at the end of the semester said it would be better if I included some programming examples, so I will add some to my videos and whatever in the different languages, and this will give me a feel for where they are. And just so that, because this one is probably of interest to people, here is the distribution of answers to that question. So 27% C++, plus 31% C#, 29% Java, a few Python, and a few others. Okay, others will be more fun. We did have somebody last semester do all of their assignments in JavaScript just because they really wanted to be good at JavaScript. It's really funny to do like large-scale matrix operations in JavaScript, but there's an entire library doing machine learning and deep learning in JavaScript, so you can do it. Okay, so these next ones are some simple pre-tests. Okay, so a bat and a ball costs $11. The bat costs $10 more than the ball. How much does the ball cost? Oops, gotta close this one off. These will all be pretty simple. These are very basic math questions. Okay, we'll give you another 10 seconds. This shouldn't take very long. Everyone got their answer in? 52, so I don't know how many we're going to get to today. So let's ask the following question. How did you check your answer? Oops. Got it. Keep switching. So how did you check your answer? So just for fun, here is the class distribution on that. Okay. 59% C, 41% B. No one went for D, E, or whatever. Good. Anyone know where E comes from? Hitchhiker's Guide. Oh, there we go. You'll find 42 shows up many times throughout the semester. I'm not sure what it's the question, but it's an answer to something, so I'll keep reusing it. So the obvious but wrong answer is C, $1. Okay, that is wrong. Why is it wrong? Right. So it's got to be $10 more. Right. So so you have to add whatever you get to $10 more than that. So it would be $1 plus $10 more than that is $11, which would be 12. Right. So the correct answer was B. Right. The correct answer was 50 cents, for which I can add $10 more. That's $1.50. Right. In this class, I will continually tempt you with obvious but wrong answers. Okay, you have to think through and figure out how you're going to check your answers. Okay, because very often the obvious answer is not the right one because you have to think through what that is. So, if it takes 5 machines 5 minutes to make 5 widgets, how long would it take 100 machines to make 100 widgets? Okay, oh, this will take a little bit longer. Last call. Okay, well, some words of caution have prevailed. So here's the distribution now. We got 70% of people got E. Okay, we got 13% for each of B and C. So who wants to explain to me why the answer is C? So that's why the answer is C. They don't get faster or slower. The obvious wrong answer is C, 100, okay? Because each machine takes 5 minutes to make a widget. If 5 machines take 5 minutes to make 5 widgets, they're producing 1 widget per machine per minute. Right? So the correct answer is E, right? 1 widget per machine in the original 5-minute windows. Now, I got to be a little careful. Is there anyone that wants to argue why the answer is not always E? Well, if the machines fluctuate efficiency, that's one possibility. Right? Okay, I can barely hear you. Right, so yeah, so working together, working independently is interesting. So in computer science, there's actually a famous book called Mythical Man Month. Anyone ever hear of that? Software engineering? Okay, not all problems are actually divisible in such a way that you can speed them up by throwing more machines at it, right? If 5 machines take 5 minutes to make a widget, and the limit is how fast the raw materials can get into the building, it doesn't matter how many machines we have, right? If there's a coordination among them, having 100 programmers. So if I turn that around, if it takes 5 programmers 5 days to make 5 programs, and they're working, but if I make 100 programmers, it might take them 10 days to make 5 programs. Because the intercommunication among them can actually slow stuff down as they argue about stuff, right? So it's not always simple linear, but so it was still, most people worked through and got this one right by checking their answers and working through that. So, but yes, the Mythical Man Month says you don't always just get to divide stuff. So, I hear the examples, right? If it takes 20 months for 2 elephants to produce a baby, how long does it take 20 elephants to make a baby? 20 months. They might make more of them, but they won't actually get done in less time. Okay, one more simple pretest question. In a lake, there's a patch of lily pads. Every day, the patch doubles in size. If it takes 43 days for the patch to cover the entire lake, how long will it take for the patch to cover half the lake? Okay, last call. Oh, 54 now. Come on, now. Okay, so most people got the answer was 42. So you're getting used to the tricky questions. Hopefully that will continue throughout the semester. So things like it must be half full on 42 so that when it doubles, it becomes full on 43. This one's actually, if you think about it visually, sort of easy to check about what's going on. So there are going to be lots of questions in the semester. This is one I borrowed from Dr. T. We know many of you are creative, but we're not seeking the most creative answers, although sometimes funny is good. I'm not a very funny guy, so you won't get near as many jokes as you might from Dr. T. But if I ask for a question like, find X, I'm not looking for that kind of an answer. I'm looking for you to actually solve for X. So we want stuff to be done in the context of the math in this class. If there's more than one available answer, choose the one that's appropriate for what's going on. Some clicker questions will be just for fun, and you'll probably be able to tell what those are going to be. So last question before we take our break, how engaging the last 5 minutes of your learning? And you'll get these kinds of questions throughout the semester. Today I did not bring a camera. Oops. Okay. Okay. It's like, no, I don't want that question. Actually, the issue was the mouse was on my screen over the slide, so it's not actually on that screen. There's two screens here. So we'll go ahead and take a 5-minute or about a 5-minute break. Be back by 9:20, and we will continue from there.
I sent you the concept of Reddit. Did some clarifications.
Okay, so can you edit it directly as a TA?
No, I couldn't edit the syllabus either.
Okay. Can you make up a quiz? Check that today, because otherwise I have to go fight with them.
In Canvas, I'm listed as a grader, not a TA.
TA, okay.
So that may be this teacher.
Chris, professional race, hack computer. Thank you. Okay. So Dr. Boult, you said that program 1 is open, and this is all the information that's up there.
Okay.
Sorry,
No.
That
That is what I need people to be doing. I don't know why. Now let's see if I forgot to publish. I made this whole thing up yesterday. Oh, man. Okay, well, that's problematic because I did a bunch of editing on it last night. First, I'm looking to see because it likes to hide stuff in funny places. Not under quizzes. Dang, it's not even a group is there. Oh, I'm in the wrong class. Gotta. Program 1. It says it's published. Now let's try editing it. Changing it. Maybe it doesn't. I didn't fill in an available date. Can you see it now?
I'm going through all the different tabs to see if it's like showing up somewhere else. I still don't see it on here.
Okay, so now look in modules and see if there's a group called programming assignments.
Not yet.
Okay, try it again.
Programming assignments, program 1.
And now it's
And there it is.
There it is. Cool. I have no idea what's up. Look on where it has like it's your schedule if you go home.
Yes, sir.
Okay. It's to do.
Okay. Cool.
due September 10th, 11:59 p.m. Maybe your to-dos don't go far. So if go to the home and scroll all the way to the bottom, if it shows, see if it shows the content. Probably close to 15 minutes. So first week is always a Zoom. When I write a book, so I don't know.
Usually like 15 minutes. So like
Just looking for parking or driving to get to right? Just driving.
so backed up like awesome buses, back all the way to the beach.
Okay. So there's a campus that doesn't use awesome lines.
Okay. So I actually see what's going on. This is just the first 4 items that are due. But if I go all the way down here, then yeah. But let me show you what we can see.
We're actually using a student view option. I just forgot to.
So we can only see program 1 right now.
You can't see any of the videos.
We can go into the syllabus and get it full in, which I've already done and subscribed to.
Yeah.
Or I subscribed to last year's so that I can find it easy.
It'll be the same. I just update the videos, not.
Oh, okay.
But the actual class videos, so the in-class videos will change. The pre-recorded ones don't.
Okay.
But that means on my modules. So can you can see the quizzes, right?
In the module?
Yes.
No, sir.
Okay. So you don't see where would quizzes show up in course content? I guess I have to have a section of a module for quizzes just as well. But they showed up in the things being due, right?
Yes. Let me see if. Oh, okay. So if I were, instead of going to modules, if I go to grades, I can choose to take the quiz. I'm not going to click on that yet because I'm not ready to. But I think I can take it.
And I'm adding them to modules now.
Oh yeah. See that?
Yeah, this is a good point. The quizzes are timed, and they're not a ton of time, so I will mention that. Thank you.
So it looks like the only week so far that you're missing is 1.
Well, that's because there is no pre-video. There's no flipped classroom for week 1. You are here.
Okay. I knew that. I was testing you. Glad to say you passed. All right. Cool. Thank you.
Okay, we're going to head and get started again. So this semester, I'm going to be doing things. Yo! Okay. So this semester, our programming assignments, which Alvin just helped me realize we're not quite up on Blackboard or on Canvas the way I wanted them to be, but they should be there now. So if you click on modules, there should now be a little tab for program 1, and there's also a little tab for quizzes. Okay. A note about the quizzes. The quizzes are timed. There are 3 questions, and I think you get 5 minutes. Because they're all directly answerable from the book, the goal is not for you to read the quiz and then go try and find the part of the chapter that has the answers. So I'm going to check how much time there is just so I don't forget. No, 3 minutes. 3 questions, 3 minutes. Okay, so that's still plenty of time to answer them. If you've read the chapter, you can still refer to the book and whatever. like one or two of them will have a figure. It's like, what is A in this figure, right? You can go look that back up, but don't dawdle once you start them, because once you start them, your 3-minute timer starts. If you have one of those accommodation forms, send me email. I will make sure that I adjust it so that your quiz times are whatever your accommodation forms say, like 4 minutes or 4.5 minutes if it's 1.5 times or whatever. It really shouldn't make much of a difference. If you've really read the chapters, you should be able to answer these in about 20 seconds each, so you got some time in case you get stuck with them. If your browser crashes or whatever, don't completely freak out. Write to me. I will probably be able to do something. I can actually see what's called a crash report as an instructor. So if you started the quiz and somehow your browser closes, the server knows your browser closes because it loses its connection. So I will have some way of adjusting that, and then we can deal with it. Any questions?
Are these multiple choice or?
They are all multiple choice. I will eventually, so these 3 are all multiple choice. Later in the semester, there might be some that are short answer, which will never be like, what's the answer to this long math question? They will be like, type in a word, right? So if I'm asking for what's the property that, if I describe a property, I might have you type in a word, but in general, I would go for multiple choice because it's a little bit easier for us to grade. Right? I can have those graded automatically because I can say what's the right answer. If you type it in, we have to do more work, and it doesn't really change your learning. We'll get plenty of those fill-in-the-blank questions on the midterm. Okay, so how many of you know what Git is? How many of you have never heard of Git? Okay, so I'm going to do a very brief introduction today. This class, all of your programming assignments will be turned in using Git. Okay, you will each have your own repo. The Git repo needs to be private because I don't want, if it's public, then other students in this class can copy from you and we won't know it. So your repos need to be private. And then you should have a repo, a directory in your repo for each of the programming assignments. It should have your source code, your documentation, your input and your output files. This will make it easier for our TA to actually grade it. And if you have executables for your platform, go ahead and include them. We will try not to have to run your executables. We will only ask for your executables or try and run them because, like, we live on Linux and Macs. How many of you are using Windows? Yeah, it's dominant. But if you put in your compiled solution or whatever, we'll only check that if the code doesn't match. If you don't include a compiled version and everything is right, we won't care. If things are wrong, it'll affect how much partial credit you can get. So very briefly, some things about Git. Actually, I'll probably just do it here. Sorry, come back. Here's the syllabus. So on modules. So I'm going to talk about program 1 first, and then I'll talk about Git. So your first programming assignment. Your first programming assignment should be something you can all do today, tomorrow. It's not very long, and if you're having a problem with this, it's really a problem about your programming. It's just, I want to make sure everyone gets a better feel for where they are while it's still time to deal with it. So, your first programming assignment, and this is not done with a partner, is to write a program that's going to use 2D arrays, aka matrices. And it's going to generate and write out 6 matrices that are described below. I'm not going to go to great detail with descriptions, but the first one has the number of rows is the number of letters in your first name. The number of columns is the number of letters in your last name. So each of you will have some variations. And then you're going to fill in the matrix, starting with the number 1, increasing by 1 as you iterate first over the columns and over the rows. So there's actually an example of that one down here. So for my name as Terry Boult, the matrix would have the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on, right? That's going to be written to a file. The name of the file would be name underscore mat1. So in this case, tboult underscore mat1.txt. Okay, so you're going to generate, the first program is really simple, generate those 6 matrices. Okay, you don't have to be really clever and write a complex set of formulas for doing it, right? They're all pretty simple. They're either going to have a for loop increasing either over rows or columns. So this one goes, iterate first over rows, then over columns. So it goes 1, 2, 3, or whatever the number is. Right? This is starting 2 and 2, so 2, 4, 6, 8, 10, whatever, right, as you go through it. So some specified order. So you can have a couple of loops, generate a matrix, write it to a file. A couple of loops, generate a matrix, write it to a file. Any questions on the first part of the programming assignment? Ryan?
We're
Neil.
expecting the first and last names to be user input or our?
Your name. Okay, so you can, if you want to do it as user input, that's fine. That's a more general program, but you can hard code it. I don't care. The program doesn't have to be interactive. It can just run. That's fine, right? So this is really eventually. So file I/O is actually important. This is one of the reasons I'm doing this. Is I had a bunch of people who said my class never got to file I/O. Well, I'm sorry that your class didn't get to it, but this class assumes you can do file I/O. This gives you a chance to work through all those problems before we actually do any real math. Okay, the second part of the assignment has just a little bit of math. You're going to actually, part 2, you're going to write a program that takes, and now this one does take, 2 file names as inputs, right? So it's program file1, file2, and so command line arguments, not interactive arguments. I don't care, they can be interactive. But it's going to take 2 file names, and then it's going to add those 2 matrices if that's possible, which if they're an array, it means first element of this array, first element of this array, add them, that's the output. But you can only do that if the 2 arrays are the same. If I have a 5 by 5 and one of these others was something that's 11 by 14, you can't add a 5 by 5 to an 11 by 14, right? So you just say error, those can't be added, and that's all you have to do. Okay, and that file produces an output called, or output is the third argument. Right? So it's going to save those in a file. And then you're going to run it, and you're going to produce things like name underscore out12, which is going to add mat1 plus mat2. And you'll do mat1 plus mat3, mat1 plus mat4, mat1 plus 5. Right? So you'll generate a whole bunch of those. Okay, and if you want to run it by hand, you can, but you can actually have a little script or another program that calls the program as many times as you need to make all combinations happen. This assignment will be turned in via Git, which I will talk about in just a second. Your repo must be private. You have to share it with both me and the TA. Chris is going to give me his account. I'll show you how to do all of that in Git in just a second. You're also going to submit it in Canvas. That's because this is also a debugging assignment in case people screw up, right? We want to resolve all those bugs this first time before it matters quite so much. So if you get really stuck with this, you'll be able to still get some points. Also because we have to make sure we know your GitHub account, because we have to pull the right people. So we're going to make scripts that pull all the code and do some stuff with them. You're going to be using the same repo for all semester. So I want you to have a repo for like CS2300 in which you have directories prog1, prog2, prog3, prog4, prog5. Yeah, there's only 5. Okay. Your second journal, which I will show you the journals in just a bit as well. In your journal, you're going to put your statements about the second journal. This week's journal doesn't have it because the program is due in 2 weeks. I want that second journal to start off with, here is my Git repo, right? So that we can clone it and make sure we can get to everything, and then you'll answer the rest of the questions. And the journal actually already says that. Any questions on this first programming assignment? If you feel this programming assignment is well beyond your abilities, then you are probably not ready for this class. Right? If this is going to take you more than 2 hours, right, you are making up some learning, that's okay. You don't have to drop the class. If you can get this done in a week, you'll be able to make it through the rest of the programming assignments. But if you can't figure out how to get the basic file I/O to do this, right, you're going to have a problem. The second program is reading a file, right? So reading 2 files, right? So you have to be able to do the file I/O. In this assignment, I left it up to you to figure out the file format. So if you want to do things like write the number of rows and columns into the file, that's okay. Later in the semester, I will be giving you my input files. So you will have to be able to read files in other formats than just your own format, but this will get you going through that beginning. Okay. So there's a link here if you do not already have a student GitHub account for which you can get free private repos. If you sign up with your .uccs.edu email, you will get private repos for free because we're installed as an institution. If you use your Yahoo or Hotmail or Gmail account, you will not necessarily get it. Okay, so you can have more than one GitHub account. Sign up with your UCCS account for there. This GitHub pack will actually include a bunch of other free software if you want it as well. So there's some cool reasons to use that. So if we now go back over here. So if I'm now logged into my GitHub, I'm not going to go through how to log in. You guys can all figure that out. So I'm now going to make a new directory, CS2300, 2300. Description. Actually, I'm going to make mine CS. Well, too late. Description. Whatever. Okay, and importantly, I could. Okay, I didn't click the private before I did it. That's what I was going to show you. Is if I finished it off and hit return. So I want to go down here and click private. And I can't actually have private because I don't have the free student account. So don't pay for this. If you signed up through that other link, you should be able to have private repos for free. But I, as a faculty member, have to pay for mine. So each one I want to add, I have to upgrade my account until I get a block of it. So, but that will let you then have your repo. So I'm going to go back to making it public for a second, just so I can continue. I'll go ahead and initialize it. I think it already created the repo. So I already hit. Okay, so depending on what operating system you're going to use and how you want to work with your system, right, you then get a set of commands you can use. You can get Git for Windows. If you go to GitHub, there's places where you can download various clients. And then you can basically use that and you can clone the directory. So if I can't read it at this angle, so this is the statement, right? I would copy to clone the directory, right? So I would say git clone and that would let me clone it for another person. So that's what I'm looking for you to turn in, is that link when you turn that in. Any questions? So the basic tutorials on Git, I will actually post a video into the class discussion. So most of you have already seen it, which I was hoping. But if a few of you have not, I will post some links on how to do that, and you can go through those. If you have any difficulties with it, it's really simple. Well, actually, I do have some slides. So we'll do some very basic things. So if I created a file, so this is more Mac Unix oriented, echo hello into hello.txt. If I do git diff, it'll show me the differences. Because there's nothing in the file, it'll say that I have a file that doesn't exist. Git status will show me the status of all my files. Git add adds a file to the repository. So the important thing about thinking about Git is it actually has, let's go to this, right? 3 views of the world: the current head, the index, and the working directory. The working directory is what you're working in now. It doesn't live in the repo. The index, the index is the stuff that's been committed but is not yet shared or pushed up to GitHub, which is the real head of the system. And then the head is where things are going on. So when I would do git status, it will show me files in my directory that are not added or not committed in the directory. And then when I do the commit, the command will push it up to the service. Now, one of the reasons, if you've not used Git, this is really useful as a programmer, because while you're working in your programming assignment, you can say, well, here's what I tried. Okay, if you tried something and you're about to execute the program, I strongly recommend that you get into the practice of committing that code at that point in time, right? So if you think there's a bug in your code, commit it, saying commit trying to get the file IO to deal with end of file or whatever your problem is, right? Save that as a commit, then edit it. How many of you have ever worked in a program and made a change and then said, oh, I wish I hadn't done that. I want the old version back. Okay, all of you probably, my guess is there's some time when you're programming. One of the things you do with Git is if you have 15 different versions of your program, because you've been making these changes, you can go back and by using this command git diff, I can see the changes I've made And actually, I can do diff compared to the head. I can do diff compared to any version of the file and see what's changed. I can instantly revert back to those by doing a command. So if I init, I can actually use a command get init to make a new directory, or I can just do it on the website. I can do it either way, and then I can clone it down. So if I start doing some changes, use your favorite text editor, make some changes, then I can do git. So here I'm just going to go through the commands, get init. I have an empty repo. This is for another class I was doing an example for. Echo, get status. It's going to show me that I'm the branch master and that I have the follow untracked files. Untracked means it's not yet in the repo. I can add, so I do get add. Now it says status. When I do status, it says new file. New file means it's here but not yet pushed. I can add a commit, so get commit -am demo message, and now it's changed the file and it's really at the head locally, and that gives me my basics. And then I can do git push, and it'll push it back up to GitHub. So push and pull, think of those as the network commands. Push says send it upstream, pull says pull it downstream. Now in this class right now, you're not going to have to do a lot, but when you're working on a team of 2 of you, I will expect to see in your Git logs work from both of you. Right? So this is part of the reason why I'm switching to using Git, because I can actually see who did what push and pull. Now, if the 2 of you are working together all at one laptop, that's perfectly fine. Then I would expect the Git commit messages to say, Sam and Ryan were working together on this, right? So that I can see, so that later on if somebody says, I did all of this and they did nothing, the logs will actually show me a lot of information. So that's part of how I'm going to manage what's going on. And that way you'll each get to see a little bit about that. So Git is relatively straightforward to use. It's good practice. Most of industry uses Git or something like Git, but Git is becoming the dominant force for that. Okay, so now on to chapter 1. Okay, so there was no video online. There actually is a video for chapter 1, but it's not one I make you watch before class. So I'm going to cover the first chapter of this today, and then chapters 2, 3, right from now on, they're all flipped. You'll have to watch those online. Okay, so we're going to talk about Descartes' discovery. So Descartes is actually famous for 2 things, and depending on how you want to view it, I think he's way more famous for his math than he is for his other thing. But does anyone know what else Descartes is famous for? I think, therefore I am, hence the shirt I'm wearing today. I teach, therefore you think. Right? My goal is not for me to think about linear algebra. I do this stuff probably in my sleep, but you guys are trying to learn this. So Descartes was a philosopher and a mathematician. How many of you have heard of Cartesian coordinates? Okay, Cartesian is Descartes' name as the name of the coordinate systems. So the way his name gets translated, he gets to play some different games. So, the idea of formal Cartesian coordinates came, and this is a tale. I don't know if it's true or not, but if in the city where he lived, apparently people were trying to figure out where do we make notes of where something has happened. So you can think of this is probably more a tale than truth, right? Some people going to hide the treasure from their town by hiding it at the bottom of the river or the bottom of the lake. So you can go out and put it in the bottom of the lake, but how do you know where it is? Okay, well, if I just put a notch on the boat that says I put it off the side of the boat here, does that work? Right? I put it right off the right-hand side of the boat. Can I find the treasure? Probably not. Okay. So the local coordinate system doesn't help because the boat moves, that changes. We really want something in the global coordinate system. Okay, so how can I do that with my boat? Let's say I actually put 2 notches on the boat. Now what can I do? So if I take 1 notch and I line it up with, say, the clock tower, and I take another notch and I line it up with the peak of a mountain, right? Those 2 things coming together, those 2 directional vectors going through my boat will say my boat has to be in exactly the same coordinates when I get those 2 things lined up. Right? And once they're lined up, then I can say it's right off the right-hand side of the boat. Right? So I can define a transformation between one coordinate system, the boats, and the global coordinate system, or a larger coordinate system, the village, based on finding some alignments between these points. So Descartes' discovery was this idea of finding transformations between multiple coordinate systems. And although we talk a lot in the book about two coordinate systems, local and global, there's really an unbounded number of coordinate systems. If I think about the computer in front of me, I have a coordinate system in which my mouse is somewhere on my screen, right? Which is that local or global, right? It's somewhere on the screen on my computer, right? Which is itself computed based on things inside the computer. But at the same time, it's also projected on the wall, right? Which is another coordinate system, which is that local or global, right? So local and global are a little bit terms I dislike, right? They're simply a coordinate system and another coordinate system, target and base, whatever you want to call them. They're not always local and global. So, so the idea, as I said, Cartesian coordinates, which Descartes in Latin is Cartesius. And the language of math and science back then was still Latin, so things got translated. And coordinate systems are what links algebra and geometry. And so we'll be playing with those a lot this semester. So if I think about a local coordinate system and I want to describe a letter, right? I want to draw something on my computer screen, a glyph, a person, or whatever, but in this case I'll just do a simple letter. I can think of describing the letter in some localized coordinate system. And this is the way all fonts and all computers are described. Previously, before we had computers, like fonts were lead. Right? They were physical things, but they weren't described the same way. But now we mathematically describe them in font files. And font files describe everything in the unit cube. Every letter is between 0 and 1. And then I can put lots of them together to make things happen in my coordinate. So when I want to place the letter D on my screen, I define a mapping between the coordinate system in which the letter D is defined and another box where I want the letter D to show up. Right? And if I want the letter D to be very large, then I'm going to take the small 0, 1 box and I can make it a big box, and now I have a big D, or I can make it a very small box. If I want the letter D to be rotated, I can make the box and I can rotate it. We're going to stick for now with some simple non-rotation coordinate systems, transformations. So if I have the local coordinate system for the letter D, and I want to put it on my screen, I can describe that transformation of a box. And again, this is non-rotational. This is just a simple scaling and translation. I can define it by saying, I want 0, 0 to go to min 1, min 2. This defines how much did I move it. And then I want 1, 1 to go to max 1, max 2. Right? So I'm going to define the upper right-hand side of my box. So if I do that, I can actually solve for all of those coordinates. So if I want to know if I have some coordinate, u1, u2, some point in this local coordinate system, where does it go in the global coordinate system? Well, I'm going to take 1 minus u1 times min, right? And that's, so I'm going to take 1 minus u1, I'm going to take this value and this value, this is going to be this point, times min 1 plus u times max 1. And the reason I'm doing is that I'm scaling this up. I'm looking at how much of the max do I use? That's this piece here. And how much of the min do I use? That's the piece I get here. And that gives me x1. Right? And the same is true for x2. So throughout the semester, just to make it clear, we will interchangeably use multiple names for our coordinate system. I can talk about xy. I can talk about x1, x2. Numbered coordinate systems become a lot easier after we leave 3. X, Y, Z you can probably get. But what's in 50 dimensions? How do I name them? Well, we name them x1 through x50. So you'll see us go back and forth. And because of my dyslexia, I will get x and y, up, down, left, right. All of those things are often going to be wrong. So if I make a mistake and I talk about x2 and I should have said x1, please correct me. Because while you may understand that I did it wrong, other people in the class may be trying to figure out, what did he do? How did he do that? So if I get those kinds of things wrong, please do correct me for everybody in the class. So these parameters, u1 to u2, we're going to call our local coordinates, or we're going to call those parameters, and then we're going to solve for x1 and x2. Now, if you actually want to derive the algebra for how to relate these, you can actually do that, because if you think about how I want to go, it actually turns out to be easier to do the mapping from global back to local, and then flip the equations to solve for u1 and u2 instead of x1 and x2. Any questions about how that transformation happens? Okay, so if you feel like you can't remember these formulas, because I never can, right? I always just derive them. I know that I need 0 to go to min, so 0, 0 is going to go to min 1, min 2. So if I put in 0 here, right, I can see that I get 0 disappear, 1 minus 0 is 1. So I get min 1, 0 times max 1 makes it 0, and it goes away. Right, so that gives me, and the same is true down here. Right, so I actually derive these equations whenever I need them. I never remember them because I'll mess up the formulas. So just to check them, if I put in 0, 0, I get 0, 0 goes here. If I put in 1, 0, I get 1 minus 1 is 0 times min 1 and max 1. So what was 1, 0, right, sorry, 1, 0 becomes max 1, min 2. So just as we had those tricky problems in the beginning, in this class it's a good idea whenever you're trying to come up with a formula, check that it's doing what you want it to do by plugging in some simple results for which you know what the answer should be. You can get those answers graphically. I want this point to go here, and I can check that. And after I've done that with enough points, I probably have a pretty good idea that the answer is actually correct. So if I actually had a actual problem and I wanted to go from given a target box of 1, 3, and 3, 5, I want to figure out where that's going to go. I can do some quick calculations with it. I can say, what's the midpoint? Well, in the original local coordinate system of 0, 1, 0, 1, the midpoint is 1 half, 1 half. So I can stick 1 half, 1 half into the equations, and I'll find out that 1 half, 1 half goes to 2, 4. Well, now you can also figure that out. Since I know the box is going from 1, 3 to 3, 5, right, I also can figure out that the midpoint is going to be 2 and 4, which is the average of min and max. Right, so I can check it another way. You don't always have to use these transformations to figure out the answer if I have enough of a verbal description. Okay. But that was pretty simple. That was really just a scaling of the box in a translation. The target box doesn't have to be square. Right? In fact, it doesn't even have to be the same orientation. So I can make the box have minus 1, 1, 2, 2 as its min and max, and that results in a distortion, a stretching. Right? If I made max less than min, what would happen? If I made max minus 1, 1, and min 2, 2, what would it look like? It would look like the same stretched letter, except it would be like this. The letter D would be upside down now, right? Because I made max go up here and min go down here, so it would literally flip it over. Then you can play games and flip them this way. So these targeted coordinate systems are really a generalized transformation, though in this case it's really only flipping and translation and scaling, right? None of these, as we've described them, do this yet. Later in the semester we'll show you how to rotate in like 2 weeks. When we talk about these, we can actually talk about what's called the aspect ratio, which is the ratio of delta 1 to delta 2, which is how much do I scale the first coordinate versus the second coordinate. So I can rewrite these formulas by collecting data and say it's min 1 plus u1 times delta 1, where delta 1 is simply max 1 minus min 1. In this formula, it's a little easier. This is, if I were to try and remember a formula, this is the one I would remember, because it's really, I move 0, 0 to min, min, right? That's why the first parts go to min, min, and then u1 becomes max minus min, and then I would scale it. Right? So that gives you, I think this formula is easier, but then I might be a little odd. So aspect ratios affect how I stretch stuff. This is useful, for example, when I want to project my computer screen to that computer screen. They might be slightly different. One might be 4:3, one might be 16:9, and you get some stretching and stuff going on. Luckily, humans are actually pretty good at quickly adapting to, oh, it's stretched. Okay, one of the reasons we're good at adapting to a stretch is because from my angle, that's already very weirdly stretched. And we're used to looking at things not always perfectly in front, so our brains are pretty adapted to doing it. So if I look at it in that coordinate system sense with the deltas, we can now get a little bit more intuition about what they're going to do. If delta 1 is greater than 1, I'm stretching. If delta 1 is between 0 and 1, I'm shrinking that dimension. And if it's less than 1, I'm reversing it. Sorry, if it's less than 0, in fact, I could say if it's less than 0 and greater than -1, it's shrinking but reversed. And if it's less than -1, then it's scaling and is reversed. And the same idea happens, right? So I can flip it over by having negative in one dimension, scale it up, scale it down. All of these are transformations you can do. Okay, so just doing the, yes? So I will be posting a video of this after class. I still recommend, however, taking notes while you're doing it. But that, so watching the videos is not a replacement for taking notes because you're not committing yourself to, this is what's important I have to remember. Right? There's a lot of stuff you're going to have to go through. Now, in terms of going from global to local, right? So we described the coordinate transformations. Here's a more interesting and maybe more realistic, and this is a clicker question. So let's assume that I had a window with a min and a max. Okay, so the pixel extents when I try and draw this on my screen, and now I want to figure out what did they click on, right? Because I move my mouse over something and I click on it. Somewhere in the computer, you have to figure out what did they click on, and that's a coordinate transformation. I know the coordinate of the mouse. Okay, what did they click on? So if a mouse returns a click on the screen with the coordinates 200 and 709, which icon was clicked? Oh, that means I'm in the wrong window. Okay, so in the clicker answers, we're talking about row 1, column 1 is A, row 1, column 2. Rows go down, columns go over. So think about, and you go ahead and chat with your neighbor for this one. We're not going to do this one twice, so if you're not sure, talk about how do you solve this. We just covered all the stuff you need to do to solve it. Somebody already picked R2D2. Okay, they got the joke. Very good question, right? So is row 1 the top row or the bottom row? So generally, there's no hard and fast answer. We can change things, but generally when people talk about rows, we number from top down. And when people talk in math coordinate systems, 0, 0 is down here. In every computer, in every programming language that does graphics, that is one of the fundamental things you have to first ask yourself. Where is the origin and what is up? In Windows, native graphics packages, things like DirectX, the world looks like this. 0, 0 is up here and goes down. In OpenGL, or any of the libraries that use 3D graphics, 0, 0 is down here and goes up. So in this case, it's hopefully rows counting down. Now I have to Okay, so to be careful about that answer. This is row 1, okay, but in these coordinates that I said where the 7 by 7 icons live, these coordinates start down here. So 0, 0 is here, and this is row 1. So you're free to use a calculator when doing these kinds of questions because these are numbers that may or may not be things you want to do in your head. Okay, so 0, 0 to 0.3, 0.1, right? So this thing down here is between 0 and 0.33 and between 0 and 0.14. Right? So that's how you interpret these numbers. These are the coordinates where these icons live, 0, 0.3, right? These are the boundaries, 0, 0.3, 0.6, and 1, and 0, 0.14, 0.29, 0.43, and whatever, going up from the bottom. How many people have absolutely no idea how to begin trying to solve this problem? Okay, we got 1 or 2. Okay, so we gave you a couple of formulas. Right? How might you use these to think about how to approach that? Again, think about these formulas. Right? You have min and max. Can you figure out what deltas are? Right? You're trying to go from one coordinate system to another. Right? So, if I give you a hint, right? If we're looking at these formulas, this tells me x in terms of u1. What we need to do is get u1 in terms of x. So how do I solve this? Well, right, if I look at this equation, I want to solve for u1. So I'm going to take x1 minus min 1 divided by delta 1. And that gives me u1. And the same is for x2. Right? So this is basic algebra solving. Is that a question? Or I saw. Okay, so can't see any people here. 35. So for those of you who have your answer, I'm going to recommend you think about how you're going to check your answer, because the majority of the class is currently wrong. Of those who've turned in an answer. Okay, so we'll give you another 15 seconds to get an answer in, and we'll talk about how to solve it. So, and this may be a continuing trend, right? If you're one of the people who's taking a little bit longer, we're gonna move on eventually. We're not gonna wait for everyone to have answered, so I will push for there to be answers, and then we'll move on. Normally, I will have a pretty good idea how many answers I should get, but we got like 54, but people might not have returned after break, so I don't even know. How many people are still working on it? Okay, that's enough that I'll give you a little bit more time instead of just answering. So for here, I've solved for what is U1, 0.17. If you didn't get that first part of it, you're probably not approaching the problem correctly. Okay, last call. Oops. Looks like I somehow killed it. So, are people, someone who's using Reef, is your app working? Because now it's telling me I've lost the connection. It's trying to reconnect. Okay, now it's back. Okay, we got 56 in. We're good. Okay. So to solve this, as I said, you're gonna solve for U1, similar to what I have here. You fill that in. You get 200 minus 120 over 48 or 480, which is 600 minus 120, gives you about 0.17. And U2, you do the same thing, except you do 709 minus 300 divided by 520. And that's again because I'm looking at the difference of those. So that gives me about 0.79, which means I am, if I go back to these guys, I'm at 0.17, 0.79, so 0.17 on the 0.7 is U1, which is this one here. So that's the first column. And then 1, 2, 3, 4, 5, 6. I'm up here. 1, 2, 3, 4, 5, 6. And so the correct answer was C, R2C1. Okay, so basic coordinate transformations. Okay, so that gets between that one, and so the answer was what I said. So now, when we talk about these coordinate systems, and throughout the semester, we're going to do 2, 3 infinity. We're going to start mostly, we're going to do some quick review for the next week or two in 2D, because I want you to have the right intuition, understand how things work there. Then we'll do 3D, which we'll do in another couple of weeks, and then we'll do the general linear algebra in dimensions. But this idea of global coordinate systems is true in everything, right? So if I'm looking at any object, right now I have 3 coordinates in 3 space, E1, E2, E3, right? Left-hand, right-hand coordinate systems are slightly different, but and you can do the same kind of transformation. So if I wanted to transform from a local coordinate system in 3D to a global coordinate system, or to a target coordinate system, right? I do pretty much the same thing, except now I have a third variable, and that variable allows me to talk about the third dimension, and it's really just the same thing. We're going to see this a lot in lots of places in linear algebra. We go from 2 to 3 by adding one more thing, and it's pretty much treated the same, which is why when we go to n, it becomes really simple. So just add a whole bunch more of them, they'll be the same, right? So if I want to do a coordinate transformation in n dimensions, I would simply have n formulas that look like this: 1 minus u1 min 1 plus u1 max 1, right? For each of the dimensions. Or if I use the other formula with deltas, it's min plus coordinate delta 1, min plus coordinate delta 2, whatever, delta 3, delta 4. You can do this for as many as you want. So what we described was inside the box, but it turns out we can use that transformation for things outside the box. We actually never said when we derived these formulas that u1 was between 0 and 1 always. We just described it by saying we're going to take 0, 1, and we're going to map it to min max. Now they have the nice property that if I start outside the box in one coordinate system, they will be outside the box in the other coordinate system. Later in the semester we'll actually derive that property. But I can find a point that is, if I have min of 1, 1 and max of 2, 3, and my local coordinate, in my local coordinate system I choose a point like 2, 3 halves, so it's 2, 3 halves, I'm outside of it, I can ask where does that go in the global coordinate or the target coordinate system. Just stick the same numbers in the formula and I'll get that that goes to 3, 4. So despite the fact the world got stretched, I can still answer what goes where. And that's really because I'm mapping a coordinate system, which is the entire 2D plane, to another coordinate system, which is another 2D plane that's scaled and translated and possibly rotated and whatever. But I can always transform any point to any point until I get to things that throw away dimensions. Then when we get to perspective projections, they'll be a little bit different. So you can do the same thing with points outside the box. So I can measure these and then talk about points that are outside of it. This gives me the ability to build a coordinate system around an object and then use it. So when we're playing with real 3D objects, and you want to get a model of your 3D object, say, into a computer graphics program and then be able to move it around and do whatever you want, you can actually do that by just measuring the object itself. So this is using a coordinate measuring machine, which actually is doing a very complicated set of coordinate transformations. The very bottom of this base is the basis of this thing's coordinate system. It knows the lengths and angles of each of these. And so when I move this tip around and I touch some point and I say mark, it actually can compute all of those angles and say, now I have gone through not one transformation. So there's the sort of right? There's the point on the cat, okay, in the global coordinate system. And to compute that, it actually says, well, I know the transformation from this point to this point because it knows the length of that rod and its angles. Then it knows this angle and whatever, and this angle and whatever, and this angle. And so it's going to relate it back to the coordinate system. And then as I move it around, every time I translate or rotate one of those angles, right, it knows all those angles. There's sensors, Hall sensors in each of the joints that measure them. And then it can basically propagate all those through. And later in the semester, we'll actually talk about sort of forward and inverse kinematics. And this is very common for anyone using robotics stuff to be able to transform from the world coordinate system to the robot's coordinate system, which is a bunch of angles that describe where everything is. And I can go back and forth between them. With all the angles, it's way more complicated than just min-max. All we describe right now is this move it around kind of thing. As we go throughout the semester, we'll learn how to rotate, scale, translate, and deal with all of the angles. But as I said, there are lots of coordinate systems. We'll see them all the time. So inside your phone, you have two very natural coordinate systems. If you're drawing on an iPhone, you have a screen graphics coordinate system for which 0, 0 is the upper left, and X and Y, X increases left to right, Y increases down the screen. Okay. But if I ask for the accelerometer in my phone, the accelerometer in my phone has a coordinate system where X is left or right on the phone, Y is towards the top of the phone, and Z is out of the screen. Right? So you have different coordinate axes, right? So X and Y, so are they X and Y, sorry, yeah. X and Y is actually a left-handed coordinate system when Y goes down. So X and Y, okay? And Z comes out of the screen if I'm looking at it that way. But if I'm using the accelerometers, I have a right-handed coordinate system and I have X, Y, and Z coming out of the screen. So you have two very different coordinate systems, even in the same device, depending on what you want to look at them from. And then, of course, I don't even have to have these nice simple things. I can have the world's coordinate system, for which we tend to use Latin ln, on a particular spheroid, because it's actually not a perfect sphere. Latin ln describes points on the globe, so I can describe things in that way. I can have mappings between simple linear things. Now that same rectilinear grid I can turn into a tube, so I can have cylindrical coordinate systems. I can actually also turn it into a torus, okay? And I can do that in ways that don't lose any information, although both of these have one odd property, which is compared to this, where this goes on forever, right? And I can keep having larger and larger volumes. As soon as I turned it into a cylindrical coordinate system, where's my mouse? Now one of the dimensions is finite, because it goes 0, 1, 2, 3, right? So if I think of it as degrees, I go 0 to 360, and then 0 to 360. So it's periodic, but finite, where in this case it's infinite. So I'm taking a finite grid and turning it into a finite tube. I can have 3D cylindrical coordinate systems. I can have weirder coordinate systems. This is a color coordinate system called hue, chroma, and value, also hue, saturation, and value. So this is a space that actually looks like a little pyramid, because when I have very small brightness, I really can't get much difference in saturation and chroma. It's just all dark, so I can't get all the different colors. So the perceivable color space is a very weird space. And then we can even have very odd object-specific coordinate systems. I do a lot of work in face recognition. And in face recognition, we actually talk about face space, where we actually talk about the mean shape of faces, and I can parameterize transformations between one face and another. And if you've ever seen people do face warping and morphing, right, I can actually take one face and one expression, map it to a set of points, and then I can use those points to transform one face with one set of facial expressions through a continuous process into someone else, right? Because I'm going to take the geometry and transform it at the same time, apply some color blending, right? All of this is coordinate transformation, right? It's just a bunch of, in this case, it's triangular patches. If you look back up in the face, you can actually see each triangle. Graphics engines are driven generally by having a bunch of triangles. So you take all those triangles, you put color on them, we call it texture mapping, and then I go from this coordinate system to another coordinate system through a set of transformations, and I tell the graphics engine to just keep rendering it, and I can make that happen. So you can do all these weird things in a face-based coordinate system. Now you don't have to think of those as a face-based coordinate system. You can actually think of them as just a bunch of triangles in 3-space. But the triangles in 3-space don't tell me how to get from Bush to Schwarzenegger, right? That's where I actually use a face space, where I can represent them both and say, now I can come up with a continuous transformation that keeps the face all together and make it all happen. And we actually deal with other kinds of shapes where we have morphs, where we can talk about morphs between cars, between birds. Any object we want, we can sort of do this nice morph. I can always do a purely graphical morph, where I say these points move here. But it becomes much more interesting when I'm dealing with faces or objects if I can do those morphs in a way that are actually meaningful. Because if, for example, I wanted to go from Schwarzenegger to Bush, I don't really want to see his lips stretch out and a hole form in between them and get black, right? Because there's nothing there. And I also don't want his lips to stretch out and just keep being red lips stretched to be as open as Bush's mouth are. We actually want something where there's a model underneath and I can say, look, I want to see teeth, right? So that I can play a little bit more in the space. So from chapter 2, at the end of, or sorry, chapter 1, at the end of every chapter, there's a bunch of words you should know or what you should know. So you should, when you get done reading the chapter, make sure you look at those words, because any one of those words is fair game for both quizzes and for exams, clicker questions, whatever. So if you read some of those and it's like, where did the word normalized coordinates come from? Okay, so this is, again, one of the things you might, like when I went over the lecture today, I didn't talk about normalized coordinates. The chapter does. So you might have to go a little bit deeper sometimes to make sure you get all those. Sometimes it'll literally just be one sentence that showed up, because normalized coordinates are what we also can call the local coordinates in the 0, 1 space, right? Everything's been normalized so that they're in a nice space. So we have a couple minutes. We're going to do one more question. We're not going to do this one as clickers. I just want to walk through how you would solve this one because I don't want to take the time for the clickers. So if I had a triangle, right, we did squares before, right, in the local coordinate system where I have U1, U2, and I give you 3 points. If the D1, D2 coordinate system is mapped to the target box with a min of 1, min 2 of 1, 2, and a max of 3, 3, where are the coordinates of the triangle vertices mapped? So let's just start with that. So where do these points, 0.1, 0.1, 0.9, 0.2, and 0.4, 0.7, where do those get mapped in the new coordinate system? How do you set that up to solve for those? So think about it a second, and then we'll talk through the answer. But okay, so who can tell me what is delta 1? Delta 1 is 2, right? It is, where do you go? Target box is 3 minus 1 is 1. And so what's delta 2? 2 minus 3 is 1. Right, so now if I use the formula, this is 1 times 0.9, right? Plus, so this is using the other set of formulas. I would have solved it the other way, but so this is 1 minus 0.1 times min plus 0.1 times max, right? There's 2 different formulas we gave in this chapter we talked about, right? This is using the other set. So that's really, and then once you have that formula, you just apply it to all 3 points, right? And this set goes there. Okay. The second question, what local coordinate corresponds to the point 2, 2 in the target coordinate system? Right, so this is the one where we have to go backwards. So we use this kind of formula. Right, and so we get 2 minus 1 divided by 3 minus 1, which is the delta, gives us 1/2. 2 minus 2 divided by 3 minus 2 gives us 0. Right, so these formulas are just given one set of coordinate systems, use either the delta formula or the other formula to go forward or backwards, depending on how you solve this. Right? This is why I said we'll use a lot of algebra in this class. Right? If I want to get x1, I solve this for x1 and I get the other set of formulas and I can go through them. Okay, so that's it for today's class. Program 1, I strongly recommend you look at it, try and get started. My office hours are 11 to 1 on Mondays. Most programming assignments will actually be due the end of Monday. So it's due September 10th because we have the Labor Day in between, but don't put it off. Try and get it done. So if you have problems, you can come to my office hours next week or today if you have questions.
Quick question for you. So for the occupancy question that we just did at the beginning, or sorry, towards the end, I think I understood it by the end.